we want to find the least common denominator. Now, to find a common denominator, I can always just multiply them by each other. I could do 56 times 196, T3 times T2, which is T5, and that would work. The reality, though, is I don't really want that big a number. So we try to find the smallest you can. Now, I wouldn't spend 20 minutes finding the smallest, but definitely look at it and see if you can do it. When I look at something like this, the exponents are really easy. When the variables. So when I look at these variables, okay, so I got this and this. I'm just comparing exponents, and I go, okay, well, what is the largest, T3? That's my answer, okay? I want the biggest one, because I can always go up, I can't go down. So I could easily times T top and bottom by this one here to get T to the third, okay? So as far as the variable part, it's really straightforward. You just pick the largest variable of each one. If you have more, write it down, you're done. You're really doing the same thing with the numbers, but it's a little bit more complicated. So I'm going to look here. I've got 56 and I've got 196. So 56 is 8 times 7, okay? Which this is also, if I wanted to do a complete factor tree, remember doing those back, I would go, this is 4 and 2, 2 and 2, and this is 2 to the third times 7. Now what about 96 over here? Well, I might not off the top of my head know what goes into 196, but I can start and I go, well, I'm pretty sure a 4 goes into it. And I got a 49. Well, then that tells me right here I have 4 times 49. By the way, how did I know 96 goes into it? If you look at the last two digits of it, and it doesn't matter what the last two, if there's a 4-digit, still look at the last two. It's divisible by 4, the whole thing's divisible by 4. There's a bunch of divisibility rules. Don't have to have them memorized, but they're useful. We all know these things, like if it ends in an even number, it's divisible by 2. If it ends in a 5 or a 0, it's divisible by 5. If you can add up all the digits and they're divisible by 3, it's divisible by 3. The same goes for 9. They're rules. Did you know them all? No, but sometimes can be useful. Then when I come down here, this is 7 and 7, this is 2 and 2. So this is 2 to the third. I said I have 2, and I'm somehow turning this. There we go. Okay? Now, you could look at this point without breaking it down. You could go, okay, well, I can see here the 8 and the 4. I could look at this, and you could probably suss it out on your own. You could go, okay, I know what I need to do. But at the same time, I'm looking at these two numbers right here, and again, I'm looking for the largest exponent. I need a 2 to the third, because these two, I look at the biggest one. I look at the biggest here. So then I'm left with 8 times 49. I come back here and I go 8 times 49, and I get something. 392. So then 392 T to the third. This is my least common denominator. So it really comes down to, you are always looking at the exponents and you are picking the largest exponents. Okay? Hopefully that helps. As I said, you can also choose, the largest exponent absolutely works with these, but you're asking yourself, what can I multiply each one to? You always are going bigger, you're never shrinking. Obviously, if you can, like if someone gave you 2/4, I would turn it into 1/2 first. You can still reduce before you start. But once you're down to those reduced forms, then what you're looking at is you're looking at going up, because you're never going to go down. The reason I can go down here is I'm doing the same thing to top and bottom. Unless I can do that, I can't do anything about it, right? So in general, that's not, you can do that, but that's not usually what we're working with in these situations. We're needing to go up. So, largest exponent, and of each base, okay? So in this case, we needed a 2, a 7, and a t. Those were our 3 bases. We took the largest of each. That gave us that. Now, again, you could look at the 56 and go, okay, this is 8 times 7, this, and you could have went, okay, well, I need the 8 and I need the 49, and you would have got there as well, too. But this way often is cleaner and neater, but it just depends. I mean, if I was looking at something like 8 and 24, I know this least common denominator is 24. I'm not going to go to the work of rewriting this. Okay? So I've rambled enough. Hopefully I've made my point. Sometimes I just need to ramble, I guess.